100,000. That is the number of young developers that 100,000. That is the number of young developers that this doer wants to teach how to code.
I can't call him a client because I don't think he's paying us, but our youngest customer, Tanmay, he's somewhere in the audience. I think he's 13.
Please join me in welcoming to the stage Tanmay Bakshi.
So, hello there. My name is Tanmay Bakshi.
I originally started coding when I was around 5.
Age 9, you created your own app?
Yes, my first iOS app, T-Tables, which helps you learn your multiplication tables, was accepted into the iOS App Store. In fact, on Valentine's Day of 2013. I am a keynote speaker, an author, an algorithmist, and a YouTuber at Tanmay Teaches. I know that sounds like a lot, but to sum it all up, I love to share my knowledge.
Because I realize that there's this lack of resources for people to learn about technologies like AI.
I'm really passionate about machine learning technology. Out of all the different fields that this technology impacts, there is one field that I'm most passionate about, and that is the field of healthcare. I'm also working towards an app that enables me to provide artificial communication to those who cannot communicate naturally by understanding their electroencephalogram brainwaves through custom deep learning algorithms that I develop.
Madam Speaker, I ask my colleagues to join in a warm Manitoba welcome to 13-year-old Tanmay Bakshi.
Ladies and gentlemen, my joy, my friend, please welcome to the stage Tanmay Bakshi.
Hello. Hello, everyone. Welcome. Thank you for joining in today. My name's Tanmay Bakshi, and my passion is to explore technology. I love working with really all sorts of next-generation technology. Particularly, what excites me most is working with AI, what you may call artificial intelligence, or really machine learning technology from a technical perspective. Now, before I get deeper into this tech and what I'm doing with it today and really how I got started, I want to start off by saying a huge thank you to the amazing teams at AmCham Slovakia for inviting me here. As a matter of fact, it's actually my very first time in Slovakia. I'm absolutely loving it here. There's a lot more stuff planned. And in fact, this morning, I had a keynote at AmCham Slovakia's Value-Driven AI conference, which was super exciting. Talked a lot about artificial intelligence and how it can really be applied, clearing some misconceptions. It was a wonderful event. But I also want to say a special thank you to the teams here at the European Researchers Night. They put in a lot of hard work to make this possible, and a thank you to them for inviting me here as well. I'm super excited. Now, to start off, what I want to do is take a brief moment to go a little bit back in time and tell you a bit more about how I started working with technology in the first place. And to do that, what we'd have to do is travel back in time by around 11 years to around 2008 when I was around 5 years old. Now, back as a curious 5-year-old, I got into the world of technology. And I mean, I wasn't even generating episodic memories yet. But I can tell you one thing, and it's that I absolutely loved working with technology and interacting with technology. It was so immersive, it was almost like magic. And plus, my dad used to work as a computer programmer. And so as you can imagine, watching him program was so fascinating to me that I wanted to find out more. And so my dad saw that curiosity, introduced me to the world of technology back when I was 5. And really since there, my curiosity has only been growing with every single one of my questions that's answered. As a matter of fact, I started to use the internet and different books as learning resources back then. And when I was 9 years old, I had my very first iOS application called T-Tables accepted into the Apple App Store. Now, from there, I decided, well, why not go ahead and create content that helps other people create their own apps as well? And so that's why I started my YouTube channel called Tanmay Teaches, where I'd upload tutorials ranging in topic all the way from iOS app development and programming to math and science. Now, this YouTube channel made me realize that there is genuinely a lack of resources for the beginners that want to get into technology and learn how to code. And so that's why I initiated my goal to reach out to and help at least 100,000 aspiring coders to help them innovate along their journey of learning to code. As a matter of fact, I'm glad to say that so far, I'm around 14,000 people there, and I'm really always working towards this goal through numerous different media. I mean, as I mentioned, there's my YouTube channel, of course there's the books I author, there's the talks, the keynotes, the workshops that I conduct at schools, universities, conferences across the globe. Essentially, making it so that if I learn about technology, I can enable others to learn about it as well, and from there they can apply it where they believe it can make an impact. And really, the reason that I'm working towards this goal is because technology is important today, but its importance is going to be growing exponentially in the future. In fact, Mark Anderson, who you may know as the co-author of the world's first major web browser, says that in the future there will only be two types of jobs. Those in which we as humans tell computers what to do, right? And those in which computers tell humans what to do. So if you want to be on the other end of that spectrum, telling computers what to do, you've got to actually communicate with that technology and have that skill of communicating with technology in the first place. And so that's why I'm working towards this goal. In fact, to scale up the number of people I could reach out to, I started to write my very first book called Hello Swift. In fact, just around 3 or 4 months ago, my first book, Hello Swift, and my second book, Cognitive Computing with IBM Watson, were both published. And I've also partnered with McGraw-Hill Education on a brand new series of books called Tanmay Teaches series. In fact, the very first book in the series, called Tanmay Teaches Julia, is coming out this November. It's for beginners of all ages to learn about the Julia language, which is really the perfect springboard to machine learning technology. As a matter of fact, finally, speaking about machine learning, back when I was around 10 is when I started working with this technology. And back then, when I was working with tech, I started to kind of feel like I didn't have that next big thing to work towards, right? I didn't have that next challenge that I wanted to go after. And I would have eventually found something anyway. But I'm lucky. I'm lucky in the sense that I stumbled upon something that, for me at least, redefined what it meant to compute. And that was the day that I stumbled upon IBM Watson and how it not only played, but really won the Jeopardy game show against the two best human competitors on that game show, Ken Jennings and Brad Rutter. Now, quick question for all of you. I want to know who I'm working with. Who here has not heard of the Jeopardy game show? Okay, a few people haven't heard. No worries, I'll explain. But who here has heard of Watson playing Jeopardy? All right, quite a few people. That's really nice. All right, so let me give you a brief description of why this fascinated me so much. Now, first of all, Jeopardy. Jeopardy is a game show, but it's not just any game show. It's a special game show. It's not just any quiz show. As a contestant, you're given these things called clues. They're basically sentences. And a contestant has to provide a question. The answer to the question is the clue they were given. It's like a reverse Q&A show. All right, it's super complex. And these clues are filled with puns, they're filled with riddles, they're filled with wordplay, and so they're very complex to understand. Now, think about this. Watson, a computer system around 9 years ago, was able to analyze, understand Jeopardy clues, correlate them with past information that it had stored locally on its drives, and provide responses to Jeopardy clues better than human contestants could. That is an amazing capability. I mean, think about it. Nowadays, we kind of take this ability for granted. You can talk to Siri, it understands what you say. It's natural. You can talk to Google Assistant. When you take a picture, your phone knows what's in the picture. But 9 years ago, none of this was possible. Not a single one of these things existed. And for a computer to understand that sort of natural language was really unheard of. And so that's why I was so fascinated by the world of machine learning technology. In fact, before I continue, what I want to do is I want to give you a little bit of a sense of how complex Jeopardy can be. So I want to ask you a few quick Jeopardy clues and see who can come up with the responses. So here's the first one. This one's a little easy. Tickets aren't needed for this event, a black hole's boundary from which matter can't escape. I'm sure you have to know this. Come on, raise your hand. Come on, yes. Event horizon, you got it right. Did you say what is event horizon, or did you just say event horizon? You just said event horizon? All right. Now, the response, and thank you for this response, was event horizon. Now, technically, I agree. You're correct when you say event horizon. But if you were to go to Jeopardy, and if you were to say event horizon, you would lose money. Because you've got to respond with a question. What is event horizon? The answer to that question is the clue you were given. That's the idea. Let's try one more. This one's a little bit more complex. There are about 50 species of the hedgehog type of this plant, so named for its spiny fruit. Any ideas? Come on. Do you have something? No? All right. Come on. Ooh, yes. Sorry? No one has enough English? All right, no problem. Well, let me give you the answer to the clue. The answer to the clue is what is cactus. Now, this is something that usually takes a few attempts to gain. So to play Jeopardy, you have to analyze complex clues. You have to have a vast source of knowledge to query from. And then you have to phrase your response as a question. It's an incredibly complex game show. And this is what fascinated me about machine learning and artificial intelligence technology. Now, if I were to give you a brief description of what this machine learning technology is all about and how it works in the back end, I mean, I know it looks magical, right? Watson can play Jeopardy, Siri can understand your natural language, your phone knows what you're doing on it. It seems magical, but really when you boil it all down, this technology is super simple from a mathematical perspective at least. I mean, think about it. Let's just say you have some sort of unstructured data, like this picture of a dog. You as a human, you can instantly tell that, yes, this is a dog, right? That's easy for you. But then, if I were to show you a cat, right, you instantly tell that this is a cat. How do you do it? Well, you evolved to do it for millions of years, hundreds of millions of years, in fact. But here's the problem. Computers can't do that. Computers don't have the capability to tell the difference between these two images. If you ask it to classify which one's a cat, which one's a dog, it simply can't do it. Because computers work fundamentally mathematically. Like if I were to ask you, give me a list of steps, an algorithm, a mathematical list of steps to determine if an image contains a cat or a dog, I can basically guarantee that you cannot do it. And you can't do it for a very, very simple reason. It's because it's impossible. A human cannot write those mathematical rules to analyze data as complex as this. And this is where machine learning comes in. By utilizing some, what I sometimes like to call fancy math, you can automatically create a mathematical model that learns what transformations to apply to an image or to some data to understand what that data means. For example, by providing the computer with, say, 10,000 images of cats and 10,000 images of dogs, it can use a little bit of calculus in order to figure out what defines a cat and what defines a dog. And this technology, from a technical perspective, is so simple that you can implement a simple machine learning model in just 15 lines of Swift code. You don't need to understand what that means, but basically get this. What you're seeing on screen right now defines a super simple machine learning model, a neural network, a perceptron actually, and that's all there is to it. It's just gradient descent. But it enables you to do some amazing things. Now, the next task that I have requires you to understand a little bit of English, but I'm sure we can do it. There's a super simple sentence, and I want you to think about what the sentence means. I shot an elephant in my pajamas. All right? Think about the meaning for that sentence. And in a second, I want you to raise your hand and give me your interpretation of the sentence. All right? Give me your interpretation of the sentence. Come on. There has to be someone that's able to understand the sentence, interpret it. Did you have? Yes. I'm really sorry I can't hear you. You're going to need to shout. Okay, sure. So your interpretation, very creative. The elephant is wearing the pajamas, and you're hunting the elephant. You're killing the elephant. Now, that's definitely a valid interpretation. I gave you zero context. I told you nothing about this sentence. So technically, you could have a valid interpretation. There's no commas, there's no context, so you could have a valid interpretation. But does anyone else have any more interpretations of this sentence? Yes? Absolutely. You could have been wearing the pajamas, and you could have shot the elephant. Now, what does the word shot mean? Yeah, like you shoot the elephant, like you kill the elephant. Yeah, absolutely. In this case, it means you kill the elephant, but think about this. It could also mean that you take a picture of the elephant, right? So there's sorts of meanings. Is there another interpretation here where, sorry? Yes? Yeah, perfect. Thank you very much. Again, your interpretation. You're wearing the pajamas, and you're taking a picture of the elephant. Now, there are all sorts of ways you can interpret this, but there are two more that I want to share with you. So I went to a school, and I shared this sentence, and I heard a response from a student that I've never heard before. They said, there was an elephant inside of the pajamas as I was wearing them, and I shot the elephant from within my pajamas. So there are all sorts of ways that you can interpret this. But here's what happens in your mind. Let's just say you're talking to a friend. Your friend's name is Stephanie, all right? Stephanie works as a photographer, and out of nowhere, she says this sentence. Now, what your brain is doing is instantly, it's going to create a mental map of the situation. It's going to say, you know what? Humans and elephants are both animals, but only humans are usually associated with clothing. Pajamas are a kind of clothing. And Stephanie works as a photographer. What do photographers do? They take pictures. Therefore, Stephanie was most likely wearing the pajamas while she took a picture of an elephant. By piecing that all together, your brain understands what that sentence means in context. That's an incredibly difficult capability. And I'm making it sound easy, but it's actually not. Your brain is specialized for this task. Your brain was built over the process of millions of years to do this in particular. And the thing is, computers, well, computers were fundamentally designed to do a different thing. They were fundamentally designed to work with mathematical tasks. As a matter of fact, there's one more activity that I want to do, but this one is going to require volunteers to actually come up onto the stage. Now, basically, I need 2 volunteers from the audience, but you need to be fluent in reading and writing both Slovak and English. All right, raise your hand if you want to come up. 2 volunteers I need. Okay, I see you. Thank you very much. Please do come up. One more. All right, are you fluent in both Slovak and English? Wonderful. Please come up. All right, thank you. So, here's what I'm going to do. I'm going to take a sentence, and I'm going to have one of them take a look at the English sentence and translate it to Slovak. Then I'll erase the English sentence, and I'm going to have another one of them translate back from Slovak to English. Sounds good?
Do I have to say it loud?
No, you're going to do this entirely quietly. You're going to write it on the iPad. And the reason I say that is because I don't want you to see the original versions of the sentences. This is going to be like a blind translate from English to Slovak back to English. Are you good with that?
Okay.
All right, let's do this. So let's do this. Would you like to do English to Slovak or Slovak to English? Choose one. Slovak to English? No problem. So what I'm going to have you do is not take a look at the iPad. You can take a look at the audience for now. Thank you. And here's what I'm going to do. I'm going to tell you what the sentence is in just a minute, but for now, only you are going to see the sentence. All right. So you can take a look at the sentence, and you can write down your Slovak interpretation of the sentence. Now, the reason I'm doing this is because I really want to demonstrate how just a few years ago, machines were entirely incapable of this task, and now, with machine learning, they are capable of this task. So let's wait for just a moment. Now, just so you're aware of the context, the sentence that I'm having him translate is a Bible quote. It's essentially a metaphor. All right?
Yeah, I think I'm done.
Thank you very much. Give me one moment. I'm going to erase the English version. like so. And there we go. All right. Now, you may come back over. You can hold a pencil. And essentially, what I'm going to have you do is read this sentence and write down what you think it means in English. Thank you. So let's see. Now, the theory is that because we're having humans do this task, they're not going to do a word-by-word translation. They're going to understand the sentence, and they're going to recreate their understanding of that sentence in another language. Let's see. Okay, we're almost there. Wow. All right. So what just happened is I gave them both a sentence. The spirit is willing, but the flesh is weak. It's a metaphor. It doesn't literally mean that, but it's a metaphor. So I had him translate from English to Slovak. And thank you very much for translating back from Slovak to English. And the final result is the spirit wants, but the body can't. That makes so much sense. Thank you very much. Round of applause for both of them. Thank you. This is a wonderful demo. Thank you very much. Thank you. Now, it just goes to show that what happens in a human mind is not a word-by-word translation. What humans do is they understand the meaning, and they synthesize that meaning back into another language. When it comes back to English, the wording isn't the same, but it doesn't need to be. The meaning is preserved. But here's the funny part. Let's just say 5 years ago, you go to Google Translate, and you feed this sentence into Google Translate, and you convert it to Russian, and then you go from Russian back to English. Guess what you'll get at the other end? The vodka is good, but the meat is rotten. Completely different sentence. But why did that happen? Well, that happened because Google Translate doesn't understand your sentence. Google Translate is just saying, all right, I see a few words here. Usually these translate to these other words, therefore we're going to translate and then translate back. It's doing a super simple word, sometimes phrase-by-phrase translation. That's called statistical translation. Really bad. But now, today, if you go to the Watson Translator service and you feed the sentence in, you convert to Russian and back, you're going to get, the spirit is ready, but the flesh is weak. That's the power of modern machine learning. Utilizing a technology known as neural machine translation, Watson can do this really intricate understanding of what's actually happening in a certain sentence to really give you an idea of what the sentence means and then translate it to another one. Now, I'm working on many different projects that use the power of this machine learning technology in really a variety of different fields. And there are 4 in particular that I want to share with you today. And it starts off with a project of mine in the field where I believe it'll make the most impact, and that is the field of healthcare. I mean, imagine by utilizing this powerful machine learning technology in healthcare, we can save and augment millions of lives every single day. And so, I'm working towards projects, as you heard, providing artificial communication by understanding a patient's brain activity if they're unable to communicate naturally. And the first milestone in working towards this goal is an application that I call mental state recognition. The point of mental state recognition is to essentially try and recognize different mental states within people. So for example, if you're relaxing and you're not doing much, by analyzing the electrical activity in your brain, my application can say, you're relaxing. But if you're concentrating, you're doing something mentally taxing, again, by analyzing the electrical activity in your brain, my app can say, yes, you're concentrating. You're doing something that requires you to think. And so, of course, instead of just talking about it, why not take a look at a demo of mental state recognition in action? This is going to be a video demo, and I'm going to show this to you with the help of my friends, Polong and Kong. Here's the idea. Polong has an EEG headset on. This is called an electroencephalogram headset. Basically, it's a little band around his forehead, and this band has 5 different electrodes. These electrodes are sending data every 225th of a second to my phone via Bluetooth. Now, this data is analyzed on my phone through my application, and it tries to predict if he's relaxing or concentrating. If he's relaxing, the screen is green. If he's concentrating, the screen is orange. If he's relaxing, then music will play. If he's concentrating, the music will stop. All right? Now, I have him relax, and as you can see, the screen is green. But when I ask him a question, he has to think of the answer, and when he thinks of the answer, the screen should turn orange. Let's take a look. So remember, when he relaxes, music will play, the screen will be green. When I ask him a question, it should turn orange. Let's take a look.
What's your favorite TV show?
Shetland.
Okay, relax. What's 20 times 26?
520.
Very nice. What's 15 times 4?
60.
Okay, relax. What's 20 times 22?
440.
Okay.
Now that was an initial demo of mental state recognition in action, but there's more. Now this was just showing you whether they're concentrating or relaxing. But what makes it super interesting is if you then extend the application in order to control other things with the knowledge of whether you're concentrating or relaxing. So there is one clip that I'd love to show you here. Let's see if it works. Now essentially this clip demonstrates me controlling a drone with the power of this application. Essentially, I've got a test subject who unfortunately you cannot see, but you will be able to momentarily. Now, essentially what's going to happen is I've got the same electroencephalogram headset on him. And, let's see. With this electroencephalogram headset, I can gather data from him and predict if he is concentrating or relaxing. Let's see if this works. No, does it not? I think I changed the resolution. Come on. Technical difficulties. These are things that need to be set up before. Let's see. Scale back to 1080i, and there we go. You can see now. All right, there we go. You can see the video. Now, here's what happens. I've got a test subject. His name is Ali. He's sitting on a chair. He has the electroencephalogram headset on. He's sending data to my phone. Whenever he relaxes, down to a subconscious level, when he's totally relaxed, the drone will take off. When I ask him a question and he thinks about it, the drone will land. Remember, when he's totally relaxed, the drone will be in the air. Let's take a look.
As you can see, he's currently relaxing, and the drone takes off. When we continue to talk, he'll concentrate. One more thing I want to share with you. This relies on relaxation subconsciously. Even if there's a little bit of distraction, it's going to think he's concentrating. But there we go. As you can see, his eyes are open. Therefore, he's concentrating. Now he's relaxing. So let's all be a little quiet, not make him nervous, and let him relax. Yes, so one more thing to share here. Whenever the phone screen is orange.
So what happened there is because he's not totally relaxed, the drone landed. Let's continue.
Phone or Android? Use Android? Okay. Right as I ask, his brain concentrates on the question. Let's try this again. Go ahead and relax. What's your least favorite TV show? Friends, okay. Controversial decision. Go ahead and relax again. Let's do one more. Relax. Who's your favorite person? Your wife, okay. Well, okay. Relax again. You for Mac OS or Windows? Windows, okay. Again, another controversial decision. Would you rather have to use a Linux computer every day or a Windows computer every day? A Windows computer every day. Well, thinking about that made him concentrate.
And that was a video demo of controlling a drone through mental state recognition. Now, of course, there are all sorts of things that you can do with this technology. This was just one example of controlling a drone through mental state recognition. Of course, this is all powered by machine learning technology. Analyzing electroencephalogram data is incredibly complex. And by utilizing recurrent neural networks, I can do it automatically and on a mobile device. Now, there are a few more projects that I would quickly like to share with you. One of them is in the field of security, and I like to call it Heart ID. Essentially, the idea is to invent a brand new kind of biometric authentication that analyzes who you are based off of the way your heart beats. So by analyzing the electrical activity from your heart, I can go ahead and use custom deep learning algorithms to identify who you are. And the idea is to transcend all of the limitations of current bioauth systems, better than Face ID, Touch ID, and of course, iris recognition as well. Now, the way it works is that you provide my system with a bunch of examples of heartbeat data from people that you trust. And my system's going to find unique patterns in those heartbeats, and then from there, you can provide new heartbeats that it's never seen before, and it'll try to identify if they're from the same person or not. The way it works is by utilizing feature vectors that are generated by my neural networks. Essentially, here's what happens. Let's say I feed in heartbeats for me and my sister. What's going to happen is my neural network will analyze the heartbeats, and then I can take the internal state of the neural network, what it thinks of, basically, when it sees those heartbeats, and I can plot them out. And the more dissimilar they are, the more different they are, the more likely that they're different people's heartbeats. In this case, they're very dissimilar because, of course, me and my sister are different people. And so what I'd love to do now is show you a video demo of Heart ID in action with the help of my friends.
Hi, I'm Leon.
Hi, I'm Alex.
So Leon is in the front, Alex is in the back. Here's what's going to happen. Leon is holding the electrocardiogram device. So he's holding a device that's sending his heart's electrical activity to my iPad. My iPad has a machine learning model. What happened is Alex told the system, yes, this is Leon, don't worry, we trust him. We know who Leon is. Now, if Leon feeds in more heartbeat data and we click on predict, we should theoretically see identified as Leon Katznelson as the correct answer. But wait, there's more. What if an intruder tries to gain access? Well, here's what happens. Remember, Leon is in the system. Alex is not in the system. Okay, it's not been trained on his data. So, if he feeds in his ECG, what's going to happen is we're going to see this data coming in, and right as it comes in, the application is going to start looking for patterns that identify his ECG. So, if we run a prediction, as you can see, it should say, not identified as Leon Katznelson as the correct answer. And so that is a quick demo of Heart ID in action. The possibilities for this sort of technology are endless, and I hope you enjoyed the demo of ECG ID. And finally, there's one more project that I want to share with you. Again, in the field of healthcare. And the reason I want to share this one with you is because it really demonstrates the amount of biological inspiration we can get from machine learning. This is specifically in the field of audiology, where I've created a neural network that can diagnose hearing disorders. The way it traditionally worked is it would take some feature values from an audiologist, and it would try and use a neural network of mine to predict a diagnosis. This reached around 96% accuracy, which is good, but it's not what I wanted. I wanted more. And so I decided to get some biological inspiration. Now, I'm not sure if you've taken a look into Einstein, but when researchers dissected Einstein's brain, they actually found some physical things that could potentially have helped make him more intelligent than your average individual, right? More imaginative, more creative. One of the things that they found was that Einstein contained an abnormally large number of astrocytes in his brain. Astrocytes are traditionally viewed as like these glial cells that don't do very much when it comes to intelligence or thinking in the brain. But when researchers took mice And they injected proto-astrocytes, proto-human astrocytes, into their brains to give them more astrocytes. The mice with these astrocytes usually ended up becoming more intelligent, more creative than the mice without them. And so you can probably tell where this is going. What I did is I created a mathematical representation of the function of an astrocyte to have Einstein-inspired machine learning algorithms. So a machine learning algorithm that, in a way, replicates mathematically one of the things that made Einstein so special. Essentially, by creating this mathematical representation, I was able to insert it within the layers of my neural network and reach a new accuracy score of over 98%, which is something that you can see all about on my YouTube channel for an in-depth tutorial on how those mathematics work. And so that's my project in the field of audiology. And finally, before I go, there's one thing I want to leave you with. And that is a project of mine that leverages machine learning in art and creativity. The name of the project is Make Your Own Mozart. And personally, I believe that the name is self-explanatory. So instead of me talking about it, I want you to listen to it in action right now. Now, what you just heard was a clip of music that I created. But I'm not a musician, so how did I do it, you may ask? Well, what I did is I trained a machine learning system, I trained an AI system to do it for me. Now, the way I did this is by taking a bunch of piano sonatas from both Beethoven and Mozart and trained this neural network to analyze patterns from within this data in order to generate more of it in the future. Now, of course, I did retrain it on folk songs on a smaller model to keep it simpler for this demo in particular. But I know it seems like the computer's thinking. It seems like the computer is creative, but that's not what's happening at all, not in the slightest, in fact. Computers aren't creative. This is a mathematical model, and the human creativity that goes behind creating true art is irreplaceable, because there's a practically, not truly, but a practically infinite number of things that we can do with human creativity. A mathematical model is still fundamentally limited to the knowledge that you give it. And it's never going to come up with something novel or something new. And that's really why I believe we shouldn't be afraid of AI technology. In fact, I don't even like to call it artificial intelligence because that's misleading. I like to call it augmented intelligence because that's what it's all about. It's about augmenting human capabilities so we can do more with the power of technology. Thank you very much, everyone. Thank you. Thank you. Thank you very much.